Hello, good morning to everybody. Today we'll solve an example of application of differential calculus in business and economics. Actually, it is the application of differential calculus. So there are two problems. Okay, the first problem is the company has examined its cost structure and revenue structure. Has determined that C be the total cost, R be the total revenue, and X is the number of units produced are related as cost equals to 100 plus 0.1015 x square and R equals to thrice x. Revenue equation and cost equation. Find the production rate X that will maximize the profit of the company and find that profit. Find also the profit when X equals to 120 units. So another number, the demand function will be given y equals to 15 to the power minus x by 3 and x lies between 0 to 8. Where y is the price per unit and x is the number of units demanded, we have to determine the price and quantity for which the revenue is maximum. Okay. Now we'll try to solve these two problems now. So let the let us consider we are given cost equation for the first one. We are the given cost equals to cost equation what C equals to 100 plus 0.015 x square and revenue R equals to thrice x. So let P be the profit of the company and P profit equals to what? Revenue minus cost. So revenue minus cost, that means thrice x minus 100 plus 0.015 x square. So P equals to what? Thrice x minus 100 plus minus 0.1. Now we have to maximize this profit. So first differentiation, we have to take ddx on both sides. So taking ddx on both sides, we get thrice x minus 100 minus 0.015 x square. So therefore, dp dx equals to 3 will be constant, x differentiation dda 1 multiply 100 differentiation 0, this is a constant, 0.015 is the constant. So x square differentiation what? X to the power n formula, twice x. Therefore dp dx equals to 3 minus 0.030 x. That means we get the first differentiation equals to this. This is equation number 2. Okay. This is equation number 2 for maximum profit. For maximum profit, first derivatives of the profit function will be what? 0. dpdx will be 0. Therefore, 3 minus 0.030 x equals to what? 0. Because dpdx equals to 0 from equation 2. Therefore, x equals to what will be? X equals to what will be? 3 divided by 0.030. And this equals to 100 units. 100 units. That means 100 units will be produced and sold. Okay. So 100 units will be produced and sold. So first derivatives. Now we have to test whether it is maximum or minimum. Now another after this line, from differentiating equation 2, with respect to x. Okay. So d square p dx square equal to what will be? Taking differentiation on both sides of equation 2. 3 minus 0.030. Okay. So in that case, the first derivatives. So this equals to 3 differentiation will be 0. Okay. 0, and this will be 0.030 into 1. That means double differentiation of profit function will be 0.03, which is negative. Okay. So since which is negative, okay, negative. Therefore, the profit is maximum at what? At x equals to 100 units. At x equals to 100 units. So profit is maximum at 100 units. Now from equation 1, the total profit. Therefore, profit P equals to what will be? Putting x equals to 100. 300 minus 100 minus 0.015 into 100 whole square. This equals to what? This equals to 300 minus, this will be 300 minus 100, and this will be 150. So we get only 50 taka. Okay, this equals to taka 50 will be the profit at for 100 units. Again, second part. This is the first part finish. Second part will be if x equals to 120 units. If x equals to 120 units, then profit. Then profit P equals to what will be? Just from equation 1. 3, 120 minus 100, 0.015, 120 whole square. So this equals to what will be? This equals to 360 minus 100 minus this multiplication will be 216. 216. This equals to taka only 44. This 44 will be what? Profit. So this is the first part. And this is the second part. Now, second number 2 equation. Okay, now the second problem. We are given the demand y equals to 15 into e to the power minus x by 3, where x lies between 0 and 8. X is the number of units, and revenue equals to, we know revenue equals to what? Number of units into price. Actually, y is the price in the given question. The x is the number of units. So total revenue will be R. So our total revenue can be written as x into 15 e to the power minus x by 3. That means 15x e to the power minus x by 3 Therefore, revenue R equals to 15x minus x by 3, equation number 1. Now we have to find out the maximum revenue. To find out the maximum revenue, differentiating this equation 1, taking the dx on both sides, we get differentiating equation 1 on both sides. Okay, this. So this equals to 15 is the constant. Now you have to take ub, u into ddx of b plus b into ddx of u. That means UV process of differentiation. So we get x e to the power x formula what? E to the power x. But multiplying with the coefficient of x. Okay. Then minus x by 3. Differentiation of x will be only 1. So we can take common here. We can take common or multiply it 15. So e to the power minus x by 3 will be common. Then we get 1 minus x by 3. 1 minus x by 3. Okay. So dr dx. This is equation number 2. For maximum revenue, first derivative of revenue function will be 0. Therefore, we know ddx of r will be this. So 15 into e to the power minus x by 3, 1 minus x by 3 will be 0. Since this 15 is not equal to 0 and e to the power minus x by 3 also not equal to 0 for every x, therefore we get minus 1 minus x by 3 equals to 0. Since 15 into e to the power minus 3 is not equal to what? 0. It can never be 0 for between this interval 0 and 8. So therefore we get x equals to what? Only 3. So number of units will be x equals to what will be? 3. Now we have to maximize the revenue. So again differentiating, again differentiating equation 1 with respect to equation 2, this equation 2 with respect to x. So we get then d square r by dx square equals to what will be, taking ddx on both sides, double differentiation 15. So ddx of e to the power minus x by 3, 1 minus x by 3. Okay, just we have to differentiate this one, right? Now after this line d square r dx square what will be? Double differentiation will be 15. So again UV process, u into ddx of 1 minus x by 3 plus 1 minus x by 3 into ddx of minus x by 3. So we get 15 e to the power minus x by 3. ddx of 1 will be 0, 0 minus x differentiation 1, so coefficient only, okay? Plus 1 minus x by 3 e to the power mx formula, e to the power mx, just multiplying with the coefficient of 1 by 3. Okay, just UB process of differentiation, right? UB process of differentiation. Now multiplying with 15. So e to the power minus x by 3 will be common here. 15 e to the power minus x by 3 will be common. So we get minus 1 by 3 plus 1 minus, sorry, this will be minus. So we get only this term and this term will be cancelled. So minus 1 by 3 minus 1 by 3 minus minus plus x by 9. So we get these values only. So this equals to 15 e to the power x by 3 minus 2 by 3 plus x by 9. Now for x equals to 3, derivative, second derivative is value what will be? A square I, dx square equals to what will be? 15 e to the power minus 1, and this value will be minus 2 by 3 plus, just putting x equals to 3, 3 by 9 means what? 1 by 3. So we get the values what? Minus 5 e to the power minus 1. So this is obviously less than 0. So less than 0 means what? Which is negative. Okay, which is negative. Therefore, the revenue is maximum at x equals to 3 units. Okay, and the maximum revenue will be given by equation number 1, and the revenue is r equals to what will be 15 into, what was the equation? 15x e to the power minus x by 3. So 15 multiply 3 into e to the power minus 3 divided by 3. That means 45 e to the power minus 1, which is approximately, we get 16 point, which is approximately 16.55. Okay, 16.55 approximately. Okay, this is our desired result. So I hope if you do practice, you can solve these types of problem. Now we have learned how we can maximize the profit and maximize the revenue. Okay, maximize the profit and maximize the revenue. Okay, so this is the first part and this is the second part. Okay, so thanks to everybody.